Hi to everyone. In this video, let us discuss ozone, its preparation and properties, etc. Of which one here ozone. So let us see what is the preparation of ozone here. Oxygen, that means when silent electric discharge passed through the oxygen, we get which one means ozone. Silent electric discharge when passed through the oxygen we get to ozone, and it is delta H value is plus 142 kilojoules. This is at 298 Kelvin temperature. So as it is endothermic reaction, ozone is said to be endothermic product. So endothermic product means it is unstable at high temperature. It is unstable at high temperature. For that reason, we are using silent electric discharge. Okay, in this we can get 5 to 10% of ozone. We get how much percent of ozone? 5 to 10% of ozone. The ozone obtained is known as ozonized oxygen. If this 10% of ozone is not enough for us to increase its yield, we have to use which one here? Some battery to that, which one? Ozonizers. What is ozonizer? The apparatus used for the preparation of ozone is known as ozonizer. So by using battery of ozonizers and by condensing the obtained ozone in a vessel surrounded by oxygen, liquid oxygen. By this method, we can increase the percentage of yield of which one? Ozone. Okay, now the apparatus used for the preparation of ozone known as ozonizer. Two ozonizers we may use here: Siemens ozonizer and Brody's ozonizer. Okay, and one more important thing here, this is most unstable one, because here whenever if you compare, when you come to that dissociation of ozone, when we come to dissociation of ozone, ozone dissociation is involved with liberation of heat. That means delta H is negative and entropy also increases. That means delta S is positive. These two combination make delta G negative. That means if delta G is negative means what here? That reaction becomes spontaneous. So like that, but that delta H negative, delta S positive values for decomposition of ozone make the change in Gibbs free energy negative. Therefore that is spontaneous process. So that's why only ozone is thermodynamically unstable. Okay, now let us see the chemical and physical properties of which one here? Ozone. Physical properties means here we know that if you look at to the sky, you come to know the color of ozone. Ozone is a pale blue color gas, but in liquid state that is having dark blue color. Pale blue color gas, dark blue color liquid, and violet black in solid state. So these are the colors in different physical states for ozone. Okay, and then ozone is having which one here? That structure, angular type of structure you can see here. Ozone double bond we have to write here. This is a dative bond. So this is the structure of which one means here? Ozone. Okay, after that let us see the chemical properties of ozone, and especially regarding ozone what we have to discuss here. Ozone acts as both oxidizing and also reducing agent. So let us see the oxidizing properties of ozone. So now first we can give which one here? This ozone can oxidize nitrite to nitrates. That means potassium nitrite is oxidized to potassium nitrate. And another one, sulfites are oxidized to sulfates. Sulfites are oxidized to sulfates. And third one is here, if you consider that which one, moisture iodine. Moisture iodine means in presence of water, iodine is oxidized to iodic acid. But in dry conditions, iodine is oxidized to iodine polyoxide, I4O9. So these are some. Okay, we will give remaining. First to see these. Nitrites are oxidized to nitrates. Sulfites oxidized to sulfates. Moisture iodine oxidized to iodic acid. And dry iodine oxidized to I4O9. So these are some oxidizing properties. And what are the remaining properties? See here. Black lead sulfide. Black lead sulfide is oxidized to which one here? White lead sulfate. So now this is the equation. In this oxygen is liberated. So this is white lead sulfate. And another one here, what is that? All hydrogen halides except HF. So for example, if you consider HCl is oxidized to which one here? Cl2. Now what we can get? H2O plus oxygen. Except HF, remaining hydrogen halides are oxidized to corresponding halogens. So this is another oxidizing property of ozone. And another important one, when silver treated with ozone, so what happens here? Silvery white color, that is which one here? Silver is blackened when treated with which one? Ozone. So why this happened? See here. First, silver when treated with ozone, this is oxidized to silver oxide and oxygen gas is liberated. But this silver oxide react with excess of ozone and converts into again silver. But what is the difference between this silver and this silver? Means this silver will be blackened, means turns to which color? Black color. So like that, silvery white color Ag, silver, that is when treated with ozone converts into which one? Black colored silver. Okay, this is another oxidizing property. So see, in all these oxidizing properties, we are observing liberation of oxygen. Okay, then another important one here, tailing of mercury. So what is that tailing of mercury? This is one important question for any examinations. So whenever, generally mercury is a mobile liquid and that is having which one? Somewhat shining nature. So that is mercury is having lustrous and meniscus nature. Metallic luster and meniscus nature is there. But in presence of ozone, it loses its shining nature and stick to the walls of the glass tube. That process is called tailing of mercury. So loss of meniscus nature and metallic luster of mercury in presence of ozone, as a result stick to the walls of the test tube, is known as tailing of mercury. So what is the equation? Means here, mercury when treated with ozone, we can get Hg2O, mercurous oxide plus oxygen. So this is called tailing of mercury. In all these reactions, we are observing that which one here? Oxygen gas is liberated. But some reactions are there in which all that oxygen atoms in ozone are get consumed. So what are the reactions here? Sulfur dioxide when treated with ozone oxidized to sulfur trioxide. In this no oxygen is liberated. So this question they may give in competitive exams. In which of the following oxidation by ozone oxygen gas is not liberated? Means first one is which one? Oxidation of sulfur dioxide. And another one, stannous chloride in acidic medium oxidized to stannic chloride. So now what we can get to water. In this also oxygen gas is not liberated. So these are the oxidizing properties of ozone. Okay, then let us see the reducing properties of ozone. Already one reducing property we observed in that oxidizing only combinedly. So what is that? Silver oxide when treated with ozone we can get which one? Silver. So this is one of the reducing properties of ozone. And the second one, barium peroxide is oxidized to barium oxide. Barium peroxide is reduced to, not oxidized. Barium peroxide is reduced to barium oxide. And then another one also there, H2O2, hydrogen peroxide plus ozone, we get H2O plus 2O2. One speciality is there in this reaction. Both H2O2 and ozone are getting reduced. So this is come under mutual reduction reaction. That means H2O2 reduces ozone and also ozone reduces H2O2. So this is called mutual reduction reaction. So these three are reducing properties of ozone. Okay, then another one is also there, ozonolysis. Ozonolysis means what here? Unsaturated organic compounds react with ozone to give carbonyl compounds. That reaction is called ozonolysis. One easy technique is there to write the ozonolysis products. Let us see what is the technique. For example, acetylene when subjected to ozonolysis. No need to write that intermediate product. What is that? Ethylene oxide like that formed, no need to write that. Just what we need to do here, break the double bond, add oxygen to this carbon, add one oxygen to this carbon. So if you add one oxygen to this carbon, what we can get? H, C, another H I am writing, add oxygen. Here also HCH, add one oxygen, means we get 2 moles of formaldehyde. Another example I give here, CH3CHC double bond CH3, that means 2-butene. When subjected to ozonolysis, what are the products they give the question? Just break the double bond here, add one oxygen to this carbon and to this carbon also. Then we get 2 moles of acetaldehyde. So like that here. So no need to write that intermediate ozonide, ethylene ozonide like that formed, no need to write. Just break the double bond, add oxygen atoms to both ends. Like that we can get which one means that product of ozonolysis of any alkenes. So this is regarding which one? Ozone preparation and properties. That means oxidizing and reducing properties of which one means ozone. Okay, now let us see which one? Oxy acids of sulfur. What are oxy acids of sulfur? We have to see here. So see, first oxy acids of sulfur, totally 4 series. What is the first series here? Us acid series. So in us acid series, first one is H2SO3, known as sulfurous acid. And what is this name here? Sulfurous acid. And then second one is, now just replace one oxygen with sulfur. That means what we can get? H2S2O2. As extra sulfur is added to sulfurous acid. This is known as thiosulfurous acid. Then third one is, just add the above two. Above two means in Telugu language pi. So upper pi. So like that what we get here, H2S2, 3 plus 2 means 5, known as pyro. Pyro means, pi means in Telugu upper. So that upper acids are added. So pyro sulfurous acid. Pyrosulfurous acid. From this now decrease one oxygen. Now we can get H2S2O4. This is known as dithionous acid. Dithionous acid. So these four come under which one here? Us acid series. Now let us see the ic acid series. Ic acid series means the first one is which one? Sulfuric acid. H2SO4. Like in the previous case, replace one oxygen with sulfur. So now what we can get? H2S2O3. Now this is called thiosulfuric acid. Thiosulfuric acid. Now like in the previous case, add the above two acids. Means we can get H2S2O7. As we added that pi row, that means upper row, this is called pyrosulfuric acid. One speciality for this, it has sauce bond. Sauce means not eatable sauce. SOS sauce. It has a sauce bond. Now again here what we have to do? Decrease one oxygen from this. We can get H2S2O6. This is known as dithionic acid. So this acid come under which one? Thionic acid series. This acid come under thionic acid series. And if you write many number of sulfur atoms here, H2SN plus 2O6, known as polythionic acid. Polythionic acid. And last series is there, that is which one? Peroxy acid series. Last series is there, that is peroxy acid series. What is that first one here? See the first one, H2SO5, known as peroxy monosulfuric acid, or this is also called which one? Carose acid. This is also called which one? Carose acid. Okay, this is first which one? Peroxy acid. Second one is H2S2O8. This is known as peroxy disulfuric acid, or known as Marshall's acid. And one important thing in this peroxy disulfuric acid contains Sus bond. SOOS. Sus bond is present in which one? Means that peroxy disulfuric acid. So these are the different oxy acids of which one? Sulfur. Okay, now let us see the preparation of sulfuric acid. Sulfuric acid prepared by contact method. Sulfuric acid prepared by which method? Means contact method. So in that different steps are present. What are the different steps?